So now we're going to be talking about the properties of logarithmic functions and exponential functions. And some of the main properties of exponential functions are that when two terms have the same base and they're being multiplied, you can add the exponents. And when you're dividing them and they have the same base, you can subtract the exponents. Also, when you have a power to a power, meaning that there is a base to an exponent raised to another exponent, you can multiply them. And also, if you have a fractional exponent, that actually means that you can turn it into a radical expression. And some of the properties for logarithmic functions, where b is greater than 0 but not equal to 1, and x and y are greater than 0, is that when you have a product of two things inside of a logarithmic function, that can be rewritten as a sum of those two logarithmic functions with the same base. Also, when you have the division inside the logarithmic function, that can be rewritten as subtraction. And if you have something being raised to a power, like x to the n, since n is the exponent, the n is going to come up in front of the logarithmic function. These same properties apply to ln. So in an example, if we wanted to combine the terms using the properties of logarithms to rewrite as one logarithm, we can do that. So if we want to rewrite 1/2 ln x plus ln y into one logarithm, we see that there's addition. That means we can turn this into multiplication. But since there is a half being multiplied to the front, that was originally an exponent. So this is actually equal to 1 ln, and then that half, we're going to bring that up front. So it's going to turn back into an exponent. So that was originally a half as an exponent, and then plus ln of y. And since we have the product now, since we have a sum, we can turn that into a product now. And we have the ln of x to the 1/2, and instead of writing plus, now we can bring that y inside and multiply it. And this is basically our logarithmic function. But there's one final step we have to do, and that is to rewrite our exponential fraction. Because remember that an exponential fraction is just a radical in disguise. So we can take the denominator, and the denominator is something called the index. The denominator turns into the index of the radical, so the 2 goes on the outside, and then the x goes on the inside, times y. And this is our final rewritten logarithm for this expression. In this next example, since we have 2/3 being multiplied to the whole function, we can actually leave that for the very end. So let's focus on what the inside of the parentheses say. Since we have a subtraction as an operation this time, that means that we can rewrite this logarithm as a division. So we're going to keep the base the same. And in this case, since there is no base, which is an invisible 10 in this case, we can just rewrite our log as log of x squared y divided by xy squared. Now we just turn that subtraction into the division, but we still have those 2/3 up front. The next step is that since the 2/3 are in front of the equation, we know that that originally was an exponent. So we can just rewrite that as an exponent. So we have that x squared y all over xy squared to the 2/3 power. And what did a rational exponent mean? That's right. That means that it was a radical. So let's rewrite that as a radical expression. So we have log of, and now in this case, the denominator is 3. So the number on the outside, the index, is 3. And we have x squared y divided by xy squared. And this whole thing is being raised to the second power because that is the numerator. So this is our combined expression for log. In problem C, we actually don't have to worry about the parentheses. So we can just go ahead and bring on that front number up into the exponent. So we know that 2 ln x, we can turn that into ln x squared by bringing up the exponent, minus, same thing, we're going to bring up the 1/3, so we have ln y to the 1/3 power, and the same thing with 7/3, so 7/3, we're going to bring that up to the power, so we have ln z of 7/3. And now, we just want to take care of the rational exponents, so we're going to just rewrite those as radicals. So we have ln x squared minus ln y to the 1/3. So that means that we have the 3 goes on the outside of the square root, and then the y goes on the inside, minus ln of 3 goes on the outside, z goes on the inside, and then to the 7th power. So now that we have rewritten our exponents, we can now just take care of the whole, all of the signs. So ln of x squared, that's being subtracted from ln of the other y. It's cube root of y. So that means that that is being divided by y, the cube root of y, and it's also being subtracted from the cube root of 7 of y to the z to the 7th. So we can actually add that into the denominator. So we have the cube root of z to the 7th power there as well. And this is our combined function expression. With these properties, we can actually do the opposite as well and expand and write the expression in terms of elementary logarithms. So if we wanted to expand it, we would basically go backwards. So since we see that we have a multiplication, we can rewrite this as ln, and we're just going to break it up. We have the square root of x to the 5th power. Since it's multiplication, we're going to add, and we're going to have ln of y squared. And now, since we have exponents, we know that we can turn radicals into fractional exponents. So we have ln of x to the numerator is 5 over, since there is no index, the number on the outside of the radical, that is actually an invisible 2. So we have 5 over 2 plus ln of y squared. And now that we have the exponents written out, we can just rewrite this with the exponents up front. So we have 5 over 2 ln x plus 2 ln y. And this question is actually asking us to rewrite it in terms of u and v for ln x. So we have 5 over 2. Our x is being represented by u, and ln y is represented by v. So we have plus 2v. All right, let's try out one more. So in this case, we have a radical being placed all around the square root of x times y to the 3rd power. So since it's being placed around the whole thing, we want to turn that into a rational exponent before we do anything else. So let's rewrite that. So we have log of the square root of x times y to the 3rd, and then we're going to rewrite the square root as an exponent. A square root as an exponent, we have 1 over 2, because 1 is the inside power, and then the index is 2, an invisible 2. And now that we have that, we can rewrite the other. So we can pull that up front since it's an exponent. So we're going to bring the half up front, and we have log of the square root of x times y to the 3rd power. Since we have multiplication, we can also rewrite the inside as a product, as an addition. So we're going to have log, let's put parentheses around that, log of the square root of x plus another log of y to the 3rd power. Because we broke it up. Since there was multiplication, we have to break it up to addition. And now let's take care of the other radicals. So we have 1/2 of log, and then we have a square root of x. Since we have a square root of x, we can rewrite that again. X to the 1/2 plus log y to the third power. And now that we have the exponents written out, we can bring those up front. So we can rewrite this as 1/2 times 1/2 log of x plus 3 log of y. And again, we just brought down the exponents. And from here, the directions are telling us to rewrite our log x and log y as u and v. So this would just be 1/2 times 1/2 u, because log x is u, plus 3v. And we can distribute this if we want to, but we can also leave it like this, because this is our final expanded form.